Yale is one of the famous 8 so-called Ivy League universities in the American Northeast. Most of them have a long history, founded already during the colonial period. Prestigious universities, known for academic excellence and selectivity in admissions. Traditional, yes. But there is a revolution going on here at Yale.
Fantastic.
We all think of the Volvo Environment Prize as the Nobel Prize for environmental sciences. So it was crystal clear to me within 15 seconds why he had won this prize.
I was thrilled. We're all thrilled. Paul is such a wonderful example of how a university professor can conduct innovative research and then catalyze that research into solutions.
Everything that we see, touch and feel is a chemical. Whether it's the furniture around us, the clothes we wear, or the electronics that we use. Modern chemistry has been creating technological miracles, increasing the quality of life for humans. But its performance has also led to unintended consequences: pollution, waste, and poisoning.
The enormity of the tragedy of Bhopal, India is becoming more apparent this morning. Authorities now say the toxic gas that escaped from a Union Carbide plant on Monday has killed at least 1,600 people, and they say another 50,000 people may suffer serious after effects such as blindness and sterility.
More major revelations. First, America's biggest oil company secretly uses what are known as forever chemicals. They're used by industry in everything from non-stick pans through waterproof clothing to cosmetics, even though safer alternatives now exist.
We've done things so wrong for so long, we've got nothing but opportunities.
Taking common items that are used in industry or used in household products that may be toxic if they end up in the environment, and modifying their chemical structure slightly to reduce their toxicity but maintain their utility. That's the whole principle of green chemistry. And the father of green chemistry, of course, is our awardee, Paul Anastas.
When you replace a carcinogen with a sugar or starch to make a bio-based plastic, that's green chemistry. But it's not just about designing the products, it's also redesigning the way we make those products. There's reasons why nature does things differently than we do. You don't see large clouds of chlorine. You don't see lakes of cyanide, because nature does things by imparting reactivity when and where it needs it. So we don't have all of this reactivity and toxicity in nature-based chemistry.
Together with John Warner, Paul Anastas has developed the 12 Principles of Green Chemistry, a framework widely used by industry and universities.
It wasn't like we must have 12, but it's now a science. There are, I think, over 12 journals dedicated to green chemistry now. There's over 60 textbooks. Paul has done amazing work to get this to this point where it is today.
Paul Anastas has also championed the development of green chemistry networks operating in more than 30 countries, resulting in numerous actions, such as creating new bio-based plastics. But the ultimate challenge is CO2.
We have a petroleum-based economy currently. So does green chemistry use approaches to make new ways of making fuels? Absolutely. And it's not using crops or things that will compete with food or feed or land use options, but there's other ways as well. Using CO2 itself, using carbon dioxide and converting that into new synthetic fuels, not only gets away from petroleum, but also allows you to use the waste of CO2 as a fuel.
Carbon dioxide can be more than waste, it can be an asset too. Actually, Air Company, we make a luxury vodka out of ethanol that's produced from carbon dioxide. Our product in the vodka is really the ethanol itself, not the vodka. The ethanol itself is what can be used as a feedstock for hundreds of other things. One of the things right now is making sustainable aviation fuel out of that alcohol. We're taking the carbon dioxide out of the atmosphere and using it to fly airplanes, so we're making it a completely circular fuel, carbon neutral fuel.
Green chemistry is useful in addressing climate change, not only by producing new kinds of fuels, but also looking at the entire spectrum of how we generate, store, and transport our energy. We're looking at new ways of energy storage. Certainly, yes, battery technology, but also storing energy in forms such as hydrogen, green hydrogen. But the biggest reason that I am most optimistic is because I am part of a global green chemistry community, that there are practitioners around the world creating new green chemistry solutions, something that is motivating people to get higher performance, higher function, and yes, higher profitability.
One is never surprised about anything about Paul. He's always really keen to transfer the message of green chemistry to everybody.
Absolutely. I grew up in this little town south of Boston called Quincy. I love music, and I was a trumpet player from the time that I was very young. Quincy was separated from Boston by this river and this wonderful wetlands. And if you go up to where I was born, you won't see them. The bulldozers rolled in when I was about 8 or 9 years old. And I was absolutely devastated. My father was a high school biology teacher. And he said, you know, if you really care about something, you care enough to learn about it. So at that point, I really knew that I was going to be a scientist, and a scientist focused on the environment. One of the things that I get motivated by is by finding connections. Once you see the interconnectivity, you can see how those things can build off each other. The reason that I have such a diversity of books and the reason that I have such a diverse taste in music and things like that is because I love to see that interconnectivity. And quite frankly, sustainability is the ultimate in systems nested in systems nested in systems. And if we don't understand that these systems challenges need system solutions, we're not going to get where we need to be fast enough.
This is something that we really need to change our way of thinking and apply it to a better and more sustainable future.
It's almost like he's surrounded by this bubble of this colorful energy, very inspired and refreshing.
For someone who doesn't know Paul, I would describe him as being someone who has the most remarkable youthful energy and positive can-do outlook when it comes to how we make things.
I admire his determination and optimism.
He's super creative in his personal life as well as his professional life. He builds things. He uses a lathe to make pens, and he created a kayak out of nothing but wood and skin and sinew. He writes songs. And most importantly, he's married to a brilliant scientist.
You can't separate Paul from his family and friends, particularly his family. The quality that helps make him who he is, which means that the things he achieves is due in large part to that, to his heart.
In fact, this vision of green chemistry can bring us all together.
Guess what? In some cases, you'll need policy.
You can take environmental activists and industrial capitalists, and we can all work together.
There is an ongoing revolution considering green chemistry. And to be very frank, there is no option. In the future, we need to do that transition.
The real success for green chemistry will be if it disappears.
The term is going to go away because it is simply the way that we do things. Using toxic substances and generating toxic products, we want the day when that will be abhorrent and absurd. That is what we're striving for. And, 20 years in the future sounds like a good target.